Okay, now we're going to talk about the 45, 45, 90 relationship. And I do think this one is simpler to remember because the two sides are the same. This is when we're talking about an isosceles, right? Two side lengths that are the same and two angles that are the same, right triangle. And all isosceles right triangles are 45, 45, 90 because you've got that one 90-degree angle and the two other equal angles have to be split. So 90 divided by 2 is 45 and 45. So in this relationship, you've got some side length S. You've got the other side length, which is the same, also S. So some side length S, some side length S. And then your relationship with your hypotenuse is that side length root 2. Now, like I said in the last video, it doesn't really matter the letter. Some formulas, some teachers use the letter N. Some side length N, other side length N, and then the hypotenuse would be N root 2. Some formulas say A, and A root 2. The letter doesn't matter. Our unknown is the goal here when we're trying to find that missing side length. So looking at number 1, here's a nice basic one where they gave us the side length of 8. So we know the other side length is the same, and we know that the hypotenuse is the side length root 2. Done. Over here, they gave us a side length of 14. So my other side length is 14, and my hypotenuse is 14 root 2. Done. In this one, it shows the full square. This is because 45, 45, 90s are born from splitting a square in half by its diagonal. So picture that if my side length is 18, my other side length is 18 because it's a square. So this is an 18 and this is an 18. Well, what do you know? And then that missing middle diagonal is our hypotenuse, or our side length root 2. So this is just 18 root 2 for the x. Number 4 gave us the hypotenuse. Normally, it's something root 2. So here we go. This is one that requires an equation. We're going to say that that length of 18 is equal to the relationship of side length root 2. So here I go. Side length root 2 equals 18, and solve backwards. Remember that we cannot leave a root 2 in our denominator, so multiplying by root 2 over root 2 to rationalize, we're going to get 18 root 2 over 2, or 9 root 2 is the final answer. My side length of both sides is 9 root 2. Okay, over here on this one, again, a whole number has been given for that hypotenuse. So we're setting up the equation again. We're saying that the side length root 2 is equal to 8. Dividing by the root 2 to isolate the s. We cannot leave the root 2 in the denominator. So multiplying by root 2 over root 2, I'm going to get 8 root 2 in the numerator, 2 in the denominator, and that leaves me with 4 root 2 as my final side length, x. Again, last one, they gave us that 10 is the hypotenuse. That means I need to use the rule. I need to set up an equation of the side length root 2 is equal to that 10. Divide both sides by root 2. We have to rationalize that denominator. And we're going to get 10 root 2 over 2, or 5 root 2 final answer. So the top 3 were the nice, basic, easy ones. The bottom 3 gave us a whole number as the hypotenuse, and we had to work backwards in order to solve for the missing side lengths, and therefore we had to rationalize a denominator. Now, this one, just like we did on the 30, 60, 90s, this one gives us the word problem version, talking about a square, because 45, 45, 90 triangles are born from splitting a square in half on its diameter. So if the perimeter of the square is 48, okay, what's perimeter mean? Remember that perimeter is adding up all sides. And a square, since it's 4 of the same sides, it's equal to 4 times that same number. So I know if 48 is my perimeter, that I can say 4 times the side lengths equals 48. And I can solve backwards to see that my side length is 12. Did that make sense? Do you see how adding up 12, 12, 12, and 12 equals 48? And now they want the length of the diagonal. So remember that that's my hypotenuse of a 45, 45, 90. So we're going to say, okay, my side length root 2 is going to end up the diagonal as 12 root 2 for the diagonal. How'd you do? Perimeter of this next square is 20. So again, we know that since it's a square, 20 being the perimeter, that you've got to add up 4 things to equal that 20. And so working backwards, we see that each side must therefore be 5. And can you picture that? 5 plus 5 plus 5 plus 5 equals 20. And they want the length of the diagonal again, my hypotenuse, which is the side length root 2. So we know that side length root 2 is going to end up as 5 root 2. And that's it. Okay, last practice of the 45, 45, 90s, where I just want you to kind of go with it. Pause the video, see how you do, see where you're at on these. Let's see how you did. So looking at this first one, of course, they start with number 9 as not the basic one. They gave us the hypotenuse as a whole number. So this is an equation one. We're going to say that the side length root 2 is equal to that 7. And so we divide by root 2. Can't leave that root 2 in the denominator. Rationalize by multiplying by its perfect square. We're going to end up with 7 root 2 over 2. So both my side lengths, x and y, are 7 root 2 over 2. On the next one, luckily this one is a basic one. This one's saying that one side length is already 10, so do you see how the other side length is 10? And my hypotenuse is just 10 root 2. I hope you're pausing the video and trying these. Next one has a 7 already in the side length, so my other side length is 7. My hypotenuse is just 7 root 2. Now, those were all 45, 45, 90s. Boom, they threw in some 30, 60, 90s right here. Be careful, look at the corners. So here on my 30, 60, 90, I know that this over here is my 30 because the 60 is already marked. So do you see how they're not giving us the missing side length? They did not give us the basic 30, 60, 90 where I can easily go get the other two. This is the one where we need the equation. We know that the side length root 3 is equal to 20. That's the relationship of this long leg right here. So let's solve backwards by dividing by root 3. And I know that I cannot leave a root 3 in the denominator. So we're going to get 20 root 3 over 3, 20 root 3 over 3 as the side length. And your hypotenuse is double that. So the hypotenuse, 2 times 20, is going to be 40 root 3 over 3. Does that make sense? We just multiplied that front number by 2. Okay, looking at this next one, it's got another hypotenuse with a whole number. It means that you're working backwards, solving that equation. So we're going to say that the side length root 3 is equal to that hypotenuse of 20. Oh, I'm sorry. Just kidding. This is the easier one. It's not the long leg, it's the hypotenuse. We're saying that 20 is normally equal to 2 times that side length. So we just divide by 2, or picture splitting that 20 in half. Do you see that our side length is just 10, half of the 20? And so my long leg is just 10 root 3. I was trying to make that harder than it was. And finally, here's our most basic. Across from the 30, my short leg is just a nice, easy 20. When I have the 20, I know that my hypotenuse is 2 times the 20. And I know that my long leg is just 20 root 3.